Hello, it's me again. All right, so we generated our data in the kitty format. So this is what we've got. Let's see, images. Then I did like 4,000 images, and so I did 4,000 images, and I set 500 images aside for testing, and 33,500 images for training. So this is basically kind of the images we've gotten. We've randomized the people and the objects in there, plus the camera. Let's see, then we've got the labels. Let's go back here. Labels. And like this. So we got this forklift, person. So what I did is when I did the generated the data, I only asked for forklift and person. If I didn't, it would produce annotations for like the floor, the wall, everything, and I don't need that. I just need the forklifts and the people. Now here's another thing too. I already ran this through the TAO toolkit, and I did notice there was an issue with the forklifts. It kind of confused itself because like the way they had it, the schema editor where it gives it the class, the forklift body, which is like right here, the forklift body is, okay, so they have the forklift body right there, forklift body, and it's got a class of the forklift. So what they did is they classified the fork of the forklifts as forklift also. And I did notice it confused the transfer learning toolkit a little bit. As you can see right here. So what I did is there was two classes in this one item, and I don't know how that works, but I think it's best to do one class per item. You know, if you want to separate this, you know, that's good, but it kind of confused it. I mean, this is the forklift and this is the fork of the forklift. So what I did is I just called the fork. I labeled this section fork, so there's no confusion. Forklift and fork. That's all I did. And the transfer learning toolkit, you know, was much better. It didn't have a hard time. It really had a hard time kind of deciding who was what. So we did all that, and then once we did is, you know, we did it with the kitty format, and we got our final data, and then I brought it over to my TAO toolkit that I run on my Linux machine, which is running Ubuntu, and the GPU is a 1080 Ti. So we'll move over to that. So let's get rid of that. Oh. So what we did is I've got the TAO kit tool running, and we're using the object detection, the TAO, the YOLO V3 Jupyter notebook. And let's see, let's get all this stuff up here. I've got my TAO right here. This is my, where I've done my, where I put, first of all, I put my key in here. And I told them my workspace is the TAO Experiments YOLO V3. That's right there. And then where my data is going to be at is the TAO Experiments data. But in this TAO right here, this is where the Jupyter notebook is residing. It's right there. And in that, you know, that shows the specs and all this stuff, and all this stuff here. But all the output from this will be located in the TAO Experiments folder under YOLO V3. There's the data. So that's what this does. This basically mounts all my folders so they can all work together. And this just mounts it here, does more. And this is the launcher. I did this, but I've run this before, so this is, I've already installed all this. And then this is tells you kind of what you got, what, you know, what it all what it comes with when it loads on. And this is I'm preparing the data set. Well, I don't need to prepare the data set because I've already taken my data and I exported output, and then I just basically broke it into the testing and training folders. And this is the same stuff that. So there's our labels, forklift person, and then here's our images right here. You see there's 4,000 images. Randomized, and so we got that. So all I did was just put them over in the folder that your data usually goes. Like when you normally run, like when we were running when we were downloading the Kitty data set, and this is where it goes. And this is the old data set right here. I just put X behind it so it doesn't look for it. This was it. So that's that. Since we're not using that, we're using our own data. So we've done that. So we pretty much so once we get that, we go right here. We run this, and this checks us. It says we have 3,500 images, and we have 500 in the test set. This just takes a look at one of them and displays what's in one of the text files. And this is where we prepare it for the TF records. So we did that, and what it does is right there it creates the TF records. So they came here, and this is going to do the TF records. It's going to take the Kitty formatted images and put them in the TF records. That's what this does. I didn't make any changes to this because I have ping images, and this generates the TF records, and it shows up right over here. And then over here, since we have objects that are different than the ones that come with it, we need to generate new anchor points. So when we do that, I have to change this. My images are 1024 by 800. So when we generate this, this makes new anchor points, and I'll show you where they go. So we have the new anchor points right here. And then we download the pre-trained model, and these are all the ones we've chose. So even though we're running, this is the YOLO v3, our backbone's going to be ResNet 18 right here. Then so we go here, make a folder for that. We download it. We download the ResNet 18 in there. Let's see. Right here, these are pre-trained ones. I downloaded this other one. I was going to try this out, but we're going to use the TechNet 18. And then the next thing we do is we do a little more checking, and then this is where we tried do our training specifications. Now these are in the spec folder, so you go to here. Let's get rid of that. This one is the train ResNet 18 TF record. So what we've done is, as you noticed over here, this is what we need to do. When we come up here, we've generated these new anchor points right here. So that's what you got to do here. You got to put in the new anchor points for the images, your specific images. So those anchor points will go in here after you generated them. And then you do that for all the spec files. We leave this ResNet 18. If we had run if we're going to run another model backbone, that's where we change this here. Basically that's the same. Leave all this the same. You make sure originally this path didn't work the way it came, so I just make sure I set my path to the ResNet 18.hdf5 folder file, and then I'll left all this the same. Made sure this was all correct, where to get the training images. And then the other changes I made is right here. This used to say pedestrian, I changed it to person. This used to say bicycle, I changed it to forklift. Left that the same, and this used to say pedestrian, I set it to person. And then I saved it. But one of the big things that come out of this is you need to put your new anchor points in here, which you generated right here. So anyway, so we picked our model. We've got this right here is what we were looking at earlier. And then we go to run the training. So this is where we run the training. It's using this YOLO v3 train resident 18 TF record.text as its the parameters, which is here. And then it just ran it. This took about 8 hours to run this whole thing. Now I did get a little worried because, you know, I wasn't getting any results right here. I come across this, it wasn't producing any results because I kind of got worried because I thought I would just see something there. But I noticed after I'll show you that it really didn't affect anything. So then it's done, it runs it, and then we check some of our weights right here. We can check that there. And then we do like look at some more things right here, what it's been doing. Then we evaluate the train model. Like I say, was worried about this, but we got a lot of, where was it at? See all the parameters. So all the parameters we were able to use. So it did recognize it, that all the the parameters. I'd be worried if those were zeros, but I didn't get anything here, so I was kind of worried, but to no avail. Then we prune it, and then we go ahead and run it. What we do is we go back to the spec folder. We got to get the spec folder that's called retrain resident 18 TF record.text. And like I say, we put in our new anchor points, the anchor points we generated from before. Make sure our paths are correct. And then make sure our wording, like I say, I changed this was pedestrian, I changed to person. This was bicycle, I changed it to forklift. Same here. This was pedestrian, person. So they run. I noticed that, see this validation fold? I think maybe that's where the zeros were coming from, because when we run it without the TF records, there's this is replaced with the location for the test images. So maybe if we had the test images there, it would give us results up, you know, like here. It'll give us results in there, but I wouldn't worry about it because it didn't affect anything. So anyway, so here you run, this is where we run our training. This took another 8 hours to train. And this shows you some of the epochs, you know, what we've done. It runs over it again, it looks at all this, the things, how our precision's doing. And we evaluate the train model, same thing. We got zeros, but it works. Then we'll do some visualizer inference. So right here, we get some test samples, and it just takes about like 20 images from what we had. And then it runs inference on them, test them out. And then right here is where we make, you know, we can set them up to be displayed. And then right here is we display them. Now, it actually went really good. Let me see if I can get this bigger. Like right here. I mean, forklift, person, forklift. Person, forklift. I mean, I'm pleased with the results it produced. Person. What happens was, I was telling, we went in there and changed the classes of the forklift, because when they associated this front part as a forklift instead of a fork, it really confused. It would make like 10 or 20 bounding boxes around each forklift. So it was a bit confusing. So that's why I'm saying it's probably best to have, you know, class per item. Let's see. So as you can see, it works pretty good. It did a good job. Let's see what else we got anymore. Here we go. See, I turned some over. This guy's kneeling, standing, and it's picking them up. Forklift. It sees the forklift back there. Forklift. Forklift. You know, it knows that's a forklift. It knows that's a forklift. Person. So anyway, it did a good job. I'm pleased with the results. And this is where we do our exporting. So this is the stuff that we're going to take over to the Nano or Xavier NX to run it in there in DeepStream. So we get ready to do our exporting. We'll export our .elt file right there, and then what I did was, let's see, I generated in the int8 format. I did both of these. So it makes, this is the file, this export file is what you're going to take over and put into the Nano or Xavier NX, because these are all the items you're going to use to generate your engine. If you want to generate your new engine over there, or if you want to just use the components and use just the components over there, and I'll show you how to do that. So basically, I made a right here. I generated this, exported the model, and this is the FP32 version right here, and this is the int8 version right here. So I generated both of these, and then I went ahead and generated the engines right here. This is the TRT engine, the TRT engine. This one's 32, 16, and int8. That's right here. This is the int8 one right here. These are the other ones. And like these right here, these are the ones that we're going to generate over in Xavier NX or Jetson Nano. And these are just the engines right here. You don't need anything else, just the label and this engine, and you're good. But we need, if we're going to run just the ETLT version of this, then we'll need the calibration bin and the labels and all that stuff. But we'll still need the labels with this. But anyway, so that's pretty much it. And then we did it. We verified the deployed model. I did the int8 one, and so this is the what is this one? This is the TRT engine right here. This is the int8 engine that we made with this right here. And I say this is the engine. I'll show you when we get to the Xavier NX. You can actually just throw this over in there and run it. But even with the int8 engine, it produced very good results. You can see right there. These should be the results we should expect when we get to our Xavier NX or Jetson Nano. So I hope this helped. I hope I didn't confuse you guys too much. But the next video I'll have, it'll be when we actually take all this and deploy it on the Jetson Xavier NX and run a video through it and see the results we get. All right. Thank you very much. Bye. Have a good day.